Welcome to Science Up. We are looking at chemistry and this particular question. So let's read it together. How much mass of copper will be deposited when a current of 2A, the 2A is 2 ampere, is passed through a copper 2 sulfate solution for 25 minutes? So they've given us some constants. We have an atomic mass of 63.5 for copper, and also it has been given that 1 Faraday is 96,500 coulomb. So let's try to trash this particular question. Okay, having the parameters already, I don't need to bring them down again. Let's just try to answer. So, what are those things that we can consider from this question? We are looking at copper here. So, how many Faraday will liberate a mole of copper? So, let me express it. So, if we have copper like this, we can see that since what we have here is 2 as an ion, it's possible that 2 Faraday will liberate 1 mole of copper singly. So from this particular expression, we are going to be able to solve this question. Alright, let's actually go in and solve it. So if 2 Faraday can actually liberate 1 mole of this, how can we bring it and relate it to this particular question? So 2 Faraday is 2 times, of course, 1 Faraday is 96,500 coulomb. So 2 Faraday will be 2 times 96,500 coulomb. So I get 96,500 coulomb. Let me reduce the way around. So liberates 1 mole. So 1 mole, how many mass does it contain? It's given atomic mass of copper, which is just 1 mole. It's 63.5. So I put it here, 63.5. So we're actually going to do something like a relation. If 2 Faraday liberates 1 mole, how many mass will be liberated by the parameters that have been given in the equation? 2 ampere as the current and 25 minutes as the time. So take note, we're going to express everything in standard unit. This 25 minutes will be converted to what? Seconds. That one is something very simple we can do. So let's put it up here and convert it and bring it back to the solving. 25 minutes converting into seconds, that will be 25. Of course, every 60 seconds make 1 minute. So the point of reference is 60. So we'll just quickly multiply it by 60. So before I proceed, let me show you something very simple that could help. So whenever you have a conversion, you know we have a higher unit, we have a lower unit, like kilograms and grams. Kilogram is higher, grams is lower. We also have something like minutes and second. Minute is higher, second is lower. So anytime you're converting from a bigger to a smaller, you just say bigger times whatever is the point of reference. Whenever you are transferring it from smaller to the bigger unit, you say smaller divided by whatever is the point of reference. So if you should come to time now, we are converting minutes. I said we're going to convert it to the standard unit, which is seconds. So if you have 25 minutes, so you say 25, you're converting big to small. So you multiply it by whatever is the reference. In this point, the reference is 60. Everything is always 60 this, 60 this. So we're going to actually multiply it by 60. So 25 times 60. 25 times 60. Okay, so 25 times 60. Punch your calculator quickly, or if you are smart enough, solve it and give me the answer. Alright, my answer is 1,500. So that means that 25 minutes is 1,500 seconds. That is a simple way to convert. Do not forget this because it's going to be helpful. So how can we bring this idea that we've gotten now and put it here? Take note, what is going to be here is the quantity of electricity. Now, quantity of electricity, Q, is expressed as current times time. This is the quantity of electricity. So we are going to maneuver and get this quantity of electricity fitted into this point. So the current from the question is what? 2 ampere. So I just have here 2 times. Of course, whenever two things are put side by side, without any sign, quickly know that's multiplication. So that's why I put this x, this multiplication sign. So 2, which is the current, times the time. The time now is no longer 25 minutes. We've converted it into seconds, so we have 1,500 seconds. So this is 1,500 seconds. So what will be the mass that will be generated from here? If 2 Faraday gives us 63.5 grams, so what will be the mass? That's what the question is asking. How much mass? So we are going to leave here with whatever letter we like. So I would prefer we go with x. So if we go with this place with x, so we are actually going to cross multiply. So let's do a cross multiplication. This will go this way, this will go this way. So x is actually going to multiply everything we have here. So this turns to 2 times 96,500 times x equals to, since we are doing a relationship, we introduce the equals to. So also going to take all of this and multiply it and put one side. So this is going to be 2 times 1,500 times 63.5. Someone will be asking, why are we neglecting the units? If you put the unit, you don't put them. At the end, we're going to get our answer direct. So let's quickly multiply this. So 2 times 96,500. Punch your calculator quickly or you solve it quickly. It's going to give us 1,190. So quickly, 2 times 96,500 gives us 193,000. So of course, 193,000 times x is 193,000 x. Whatever you do to Paul, you do the same to Silas. So we apply it here sarcastically. So 2 times 1,500 times 63.5 apparently will give us 190,500. I told you we can neglect the units. So we're actually looking for this guy here, which is x. What can we do? We have to just do away with 193,000. How will we do away with 193,000? By actually dividing both sides by 193,000. It's just simple mathematics coming into physics, or coming into chemistry rather. So we're going to divide 193,000. Same thing here, 193,000. So this will go away. What we have left is x. So x is actually equals to, so 190,500 over 193,000. Dividing them both is going to give us 0.987. So since we're actually looking at the mass, that is grams. So 0.987 grams. You want to make it shorter by approximating it. You can actually have a result of 0.99 grams. That is the way we can actually solve from the start by expressing this to the end. It was a nice time solving this with you. Bring more questions as we explore in next and subsequent classes. Bye.